Hi there, Valerie and Kyle here on EchoSlam. Okay, imagine for a second that something you think is just, well, fact like gravity, suddenly isn't quite what you thought. Now, picture that actually happening out in space. Astronomers are finding planets, actual worlds that seem to break all the rules we have for how planets are supposed to form, how they behave. Welcome to the deep dive. Today we're looking at these really perplexing forbidden planets, worlds that according to everything we understand just shouldn't exist. So our mission here is to explore these discoveries, look at how they challenge our basic ideas about planet formation, and really push the limits of what we know. We'll try to unpack what makes them seem so impossible and what theories scientists are kicking around to explain them.
And it's really down to these amazing tools we have now. Things like the Next Generation Transit Survey, NGTS down in Chile, and missions like Kepler. These telescopes are constantly watching stars, looking for that tiny, tiny dip in brightness when a planet crosses in front. That's often the first clue. Without them, honestly, these weird planets would just stay hidden. We wouldn't even know they were there.
It's pretty incredible, isn't it? Learning so much from just a flicker of light. Okay, let's dig into this first one because it really messes with our ideas about atmospheres. So picture a planet about the size of Neptune. Now, put it really close to its star. So close that its atmosphere should have just evaporated ages ago, but it hasn't. It still has one. This is NGTS 4b, although I think Vulcan sounds way cooler.
Oh, definitely. Vulcan is much better. Yeah, NGTS 4b is what we call the sub-Neptune, about 80% of Neptune's size. And the really fascinating thing is where it is. It's right in the middle of what astronomers call the Neptunian Desert, which isn't just a name, it's a real region near a star where the radiation is so intense it basically blasts away any atmosphere. It usually leaves just a bare rock behind.
Okay, so that's the rule based on physics and lots of observations. But Vulcan, it orbits its star in just 1.3 Earth days. That's insanely fast. It should be a desert world, a rock. But it's not. It has an atmosphere. Does that just break the model?
That's the big question, isn't it? What's so odd about Vulcan is that it's the only planet of its size we found in this desert region. It's a total outlier. So the theories trying to explain it, well, they're interesting. One idea is maybe it wasn't always there. It might have migrated inwards recently, nudged by gravity from other planets perhaps. And what we're seeing is its atmosphere actually in the process of evaporating right now. Like we just caught it at this specific moment.
So we're seeing its last gasp, basically. A slow motion planetary death.
Kind of, yeah. Or the other possibility is that its atmosphere used to be way, way bigger, much larger in the past. And it's been slowly losing it over millions, billions of years, and we've just happened to find it near the end. The final round of the show, as one scientist put it. Either way, watching this happen even slowly tells us a lot about how atmospheres evolve under extreme conditions. It's a rare glimpse.
Right, like watching erosion happen, but on a planet super fast forwarded, cosmically speaking. Okay, so from planets too close, let's talk about planets that are just too big for their star. And sticking with NGTS, they found another one that's a real puzzle for planet formation. NGTS 1b.
Ah yes, NGTS 1b. Now this one is a hot gas giant, almost exactly the size of our Jupiter, so massive. But the really weird part, it's orbiting a tiny red dwarf star, only about half the size of our sun. And this just throws up a huge question for formation theories. How does such a huge planet form around such a little star?
Okay, wait, so planets form from that disk of gas and dust around a young star, right? The protoplanetary disk. And the star size kind of dictates how much stuff is in that disk to begin with. Smaller star, less material.
Exactly. You've nailed the problem. According to our models, there just shouldn't be enough raw material, gas, and dust in the disk around a star that small to build a Jupiter-sized gas giant. It's like finding a great white shark in your bathtub. The scale is just wrong based on the environment it formed in. When this was found back in 2017, it was totally unprecedented. It forces us to rethink, the relationship between star size and planet size. Maybe red dwarf disks are denser than we thought, or maybe gas giants can form differently, more efficiently, around small stars. We just don't know yet.
That's wild. And is it still just the one example, or are astronomers finding more of these sharks in bathtubs?
Well, they're definitely looking harder now. It's still largely an outlier, which makes it hard to build new theories around. But yeah, it spurred a lot more scrutiny of red dwarf systems. Are there more? Or is NGTS 1b just a one-off cosmic fluke? Either answer is pretty interesting.
Okay, so too close, too big. Now for one that maybe shouldn't have formed at all and is kind of doomed. Let's talk about Kepler 78b.
Kepler 78b. Yeah, this one's both amazing and a bit terrifying. It's about Earth size, probably rocky, similar density to Earth, but its orbit. It makes Vulcan look like it's taking a leisurely stroll. A year on Kepler 78b is just 8.5 hours. Think about that. Mercury is what, 36 million miles from our sun? Kepler 78b orbits its star at less than 1.5 times the star's own diameter.
Whoa, that's practically skimming the surface. Okay, and here's the kicker, right? It's getting closer, it's spiraling inwards, doomed to be swallowed by its star eventually. But okay, forget its fate for a second.
Right. The really big mystery isn't where it's going, it's where it came from. Our current theories have no good explanation for how a planet forms that close. Even migration, like we talked about with Vulcan, doesn't really work here. The gravity is so intense it would likely just crash straight into the star if it tried to move in from further out.
So it couldn't form far out and move in, and it couldn't form right there where it is now.
So that's the baffling part. And get this, back when the planet was forming, the star itself would have been even bigger than it is now. Young stars are puffier, which means Kepler 78b must have formed inside the star's original larger radius, like inside the star's early extended atmosphere, or the very inner edge of the disk. That just doesn't make any sense with current physics. How do you build a rocky planet inside a star? It contradicts everything we think we know about accretion. Scientists are hunting for more like it, desperate for clues, because this one really shakes the foundations.
It really feels like the universe is just messing with us sometimes. Okay, let's flip completely. From super hot, super close, doomed planets to something incredibly cold, dark, and unbelievably far away. Meet HD 1069 Arrow 6b, or let's just call it Bob, makes it friendlier.
Bob works for me.
Yeah.
And Bob is enormous, about 11 times the mass of Jupiter, a real giant. But what's truly unique about Bob isn't just the size, it's orbiting two stars, a binary pair. And it's doing it at this mind-boggling distance, 69 billion miles away from the central stars.
69 billion. Hang on, Neptune is like under 3 billion miles from our sun, right? Bob is over 20 times further out.
Yeah, roughly 25 times further than Neptune. It's way, way out there in the cold darkness. A region where you'd expect maybe some icy debris, not a super Jupiter.
And isn't the whole system really young too, compared to our solar system?
That's right. The HD 106906 system is only about 14 million years old. Our solar system's had 4.5 billion years. So this is just a baby, cosmically speaking. And that just adds to the puzzle. How does a planet that massive form so far from its stars, especially so early in the system's life? Our standard model says planets form from that disk, closer in where there's enough material density. Forming Bob way out there, it challenges that core idea.
So if it didn't form the normal way out there, what are the ideas for Bob? Are we talking totally different ways for giants to form?
We might be. Two main ideas are on the table. One is maybe it did form closer in a more standard way, but then got kicked out. Like complex gravitational interactions early on could have flung it way out to the boonies. That kind of chaos happens. But there's another more radical idea. The failed star hypothesis.
Failed star. Okay, that sounds cool. What does that mean? Does it blur the line between planet and star?
It absolutely does. The idea is maybe a big clump of gas started collapsing under its own gravity, aiming to become a star, but it just didn't quite gather enough mass to ignite nuclear fusion in its core. So instead of a star, it just became this enormous gas giant planet, a substellar object. If that's right, it suggests a whole different way for these supermassive distant worlds to form, completely separate from the usual disk process. Challenges our definitions.
Wow, okay. But these impossible worlds might not all be light years away. There's that whole mystery potentially right here, our own solar system, isn't there? Thinking about Pluto, Planet, not a planet. What's the latest on that and this whole Planet 9 idea?
Yeah, the Pluto story is a good example of how things change. It was discovered in 1930, hailed as Planet 9, but then starting in the 90s and early 2000s, we found tons more objects out there in the Kuiper Belt beyond Neptune. Some, like Eris, are even more massive than Pluto. So the definition of planet got refined. One rule is a planet has to clear its neighborhood gravitationally. Pluto and Eris are swimming in the Kuiper Belt debris, so they didn't make the cut. Became dwarf planets.
Right, so that seemed to settle the Planet X thing. Pluto was kind of it, just not a full planet. But then the idea came back.
It did, yeah. Much more recently, around 2016, astronomers like Badajian and Brown and others like Lee and Adams noticed something really weird. Not Planet 9 itself, but the orbits of several extremely distant objects way out beyond the Kuiper Belt. They're all tilted and clustered in a strange way. It looks like their orbits are being shepherded, gravitationally influenced by something massive and unseen, way, way out there. Planet 9 or Planet X.
Okay, so how far out are we talking for this potential Planet 9, way beyond Pluto?
Oh, way beyond. Estimates vary a lot, but we're talking maybe 40 billion to 140 billion miles from the sun. That's 400 to 1500 times farther out than Earth. Light would take days, maybe a week to get there from the sun. It's incredibly remote, dark, and cold. And the big problem is, just like Bob, our models say a planet shouldn't form out there. The raw material in the early solar system was just too sparse that far out.
So another impossible formation. If it couldn't form there, how might it have gotten there? Was it chucked out from closer in or maybe captured?
Those are the main theories being batted around. The sort of leading idea is that it formed much closer to the sun, maybe like Uranus or Neptune, or even a bit bigger, a super Earth. But then during the early solar system's chaotic shuffling phase, it got into a gravitational tussle with Jupiter or Saturn and was flung way, way out into this distant orbit. We know planets got ejected back then.
And the other idea?
The other involves a close pass by another star, early in the solar system's history. Such a flyby could have gravitationally grabbed a planet that was forming further out and yanked it into its current weird tilted orbit. Stellar flybys were probably more common back when the sun was forming in its birth cluster.
Okay, so ejection or a stellar nudge. Which one looks more likely? Or is it still just guessing?
Well, here's the thing. When they run simulations, getting either of those scenarios to produce the specific orbit that seems to fit the evidence, it's tricky. The chances are estimated pretty low, maybe only 2% to 10% likelihood for those explanations. So, honestly, if Planet 9 is eventually found, its origin is still a massive question mark. It might mean our models of how solar systems settle down are missing something really important. We need to find it first, though. Only time and a lot more searching will tell.
It's just incredible. We've gone from planets clinging to atmospheres they shouldn't have, to giants orbiting tiny stars, to worlds about to be eaten, to giants lost in the dark, and maybe even one hiding in our own cosmic backyard.
Absolutely.
Yeah.
These impossible planets are fantastic because they force us to rethink everything. Every discovery like this makes the universe seem, well, more complex, more surprising, and way more exciting. They're showing us that nature is far more imaginative than our theories sometimes allow for.
Yeah, they're not just data points, are they? They're pushing us to question our assumptions, to imagine new possibilities. It's like the universe is constantly daring us to figure it out.
Exactly. And maybe that leaves you with something to think about. What new physics, what deeper understanding might these impossible planets be hinting at? Could they be the first clues to something fundamental about the cosmos that we haven't grasped yet?